Okay, so here's a past exam question just to help you fully understand how to operate these things, right? So we've got a builder wishes to build houses and flats on 6,000 square meters plot of land. The city council insists that there must be more than 6 houses and there must be more flats than houses. Take X to represent the number of houses. So we're told X is going to represent the number of houses. And then take Y to represent the number of flats. So Y is going to represent the flats. Right? Write down two inequalities other than X is greater than 0 and Y is greater than 0. Right? Meaning don't write these ones. Right? Which satisfy these conditions. So what two inequalities can we write? The first one is we're told that there must be more than 6 houses. Therefore, X, which is the number of houses, must be greater than 6, right? So X must be greater than 6. The number of houses must be more than 6, according to this question here. Then we're told that there must be more flats than houses, meaning the number of flats must be more than the number of houses. So the number of flats Y must be more than the number of houses X. So those are our two inequalities that they're looking for. Okay? Now, they said the builder allows 300 square meters for each flat and 400 square meters for each house. Write down another inequality which satisfies this condition and shows that it reduces to that. Now, what you need to know is that the amount of space taken is going to be equal to the space taken by flats. Let me just put houses first. It's going to be equal to the space taken by houses and the space taken by flats. So the flats, the houses first, each house takes 400 square meters. That's each house, right? So the total space taken by houses will be 400 times the number of houses X, right? And then each flat takes 300 square meters, right? So the total amount of space taken by flats is going to be 300 times the number of flats. But we know that the total amount of space is 6,000. So the space taken by houses plus the space taken by flats must be less than the total amount of space. Otherwise, the houses and flats will not fit there, right? So that's what I'll do. I'll say, okay, the space taken by houses, 400x, plus the space taken by flats, 300y, must be less than or equal to the total amount of space, 6,000. Once I get here, I can reduce this by dividing by 100 throughout, right? 100 is the largest number that can go into all this. It's the highest common factor, which will give me 4x plus 3y is less than or equal to 60. They asked us to show that it reduces to this. 4x plus 3y is less than or equal to 60, and that's what we did. We've shown it. Okay? And now, they said, part C now, the point xy represents x houses and y flats. Using a scale of 2 centimeters to represent 5 units on both axes, draw the x and y axis for both values of x ranging from 0 to 20 and values of y ranging from 0 to 20. So they said 2 centimeters represents 5 units. So on your graph, you must remember there must be 2 centimeters between the 5s. 2 centimeters. So 2 centimeters, 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 2 centimeters. So they said, now construct and show by shading the unwanted regions in which the xy must lie. So we need to draw our 3 inequalities that we've come up with. The first one being x is less than 6, right? X is less than 6 is our first inequality. So I'm going to draw here, our 6 is somewhere here, right? So we're going to have, okay, our 6 is probably somewhere here. So we're told that x is greater than 6. I was saying x is less than 6. X is greater than 6. So x is greater than 6. We shade the unwanted region on that side. Then the next thing is y is greater than x. So for that one, we need a table of values, right? We pick two x values. Remember, the values must correspond with the scale. The scale is in 5s and 10s. So I'll probably put 5 and 10. When x is 5, y is 5 as well. When x is 10, y is 10 as well. So 5, 5, 10, 10. So 5, 5, 10, 10. So it's y is less than x, so I put a dashed line as well. So this is y is what? Is greater than x. So y is greater than x. So I want what is above, I shade what is below that line. The last thing is drawing this one now. 4x plus 3y is less than or equal to 60, right? So let me just erase a bit and make space for my table of values. So I can draw my table of values there. If my values of x and values of y. So for x, I can have 0, and I can put 0 and 15. When x is 0, y is going to be 20. When x is 15, y is going to be 0. So 0, 20, 15, 0. So I'm using the most convenient ones. So 0, 20, what can I use here? So 0, 20, 15, 0. And then less than or equal to, so it's a solid line. So I draw a straight solid line, okay? So that's going to be 4x plus 3y is less than 60. 4x plus 3y is less than or equal to 60, right? So less than means I shade above, right? Once I shade above, we've got our little space in here. That's our region, right, that we're looking for. So we're done with that part C. We've drawn our inequalities. So we've done this, we've done that, and we've done that, right? Now, it's saying use your graph to find the maximum number of flats that can be built. We know flats are y, so we're simply looking for the largest y value that we can find in that region. So in this region, the largest y value we can find is probably somewhere here, which is probably, that's probably 13, right? So the largest number of flats that can be built is probably 13, right? I advise you to take graph paper and draw this to scale and actually find the accurate number. The maximum number of houses that can be built. Houses are x, so we're looking for the largest x value that can be found in that region. So the largest x value in that region is probably somewhere here. If we come down here, that's looking like an 8, right? A 7 or an 8. So it's probably an 8. That's the largest number of houses that can be built there. The values of x and y, which give the maximum number of dwelling units, right? So again, you look at the corners like what we did the first time, right? You're going to look at the corners of that region, and I'm going to highlight those corners. Maybe let me use yellow. So probably you're going to have this, and then look at somewhere there, and then look at somewhere there. So this first part here gives you maybe 6, 13. This one here gives you 7. What did you put? Did you put 8 or 7 there? You put 8. So it gives you 8. So whenever I ask to find the maximum, minimum, 8, and our y value is probably a 9. And then this one gives you a 5 and 6. 5, 6. So number of dwelling units is going to be number of houses, right? Number of dwelling units is going to be x plus y, right? So we're going to see of these 3 points, 6, 13, 6, 13. The other point is what? 8, 9. The other point is 5, 6. 5, 6. All these are x and y values, right? So we want the combination that gives us the largest number of x plus y. So 6 plus 13, that gives you 19 dwelling units there. 6 houses and 13 flats, 19 dwelling units. 8 plus 9, that's 17 dwelling units. 5 plus 6, that's 11 dwelling units. So the maximum number of dwelling units is 19. That's when you have 6 houses and 13 flats. Okay, so that's what they want. They want the values of x and y, which give you the maximum number. It's 6 and 13 there. So that's complete, and that's how you get your 12 marks in the exam. This is a past exam question paper, and you can easily try more now that you know what you did. So this is easier when you use your graph paper and then there's measurements, so it becomes clearer. You can do better from the knowledge that you've obtained from my sketches.